Hello, everyone, and welcome. Welcome to our surgical robotics themed webinar today at Robo Global. We are so excited today to be presenting to you not just people from Robo Global talking about investing in new technology and innovation, but we've got some key opinion leaders and industry execs specifically from the surgical robotics industry. And so we're really excited to dive in and explain to you investment opportunities in this space and really ways that you can bring exposure to this to your portfolio. So without further ado, why don't we just jump in and I'd like to introduce our speakers to you. We've got Matthias Glastra. He's the CEO and chairperson of the board at Noventa. This is a $5 billion market cap company that focuses largely on the enabling technologies that go into building robots, both industrial and medical. And automation technology as well. We also have Adam Sachs. He's the founder and CEO of Vicarious Surgical, a recent SPAC in the med tech space. And Adam brings with him to Vicarious training from MIT as a roboticist. And he is revolutionizing minimally invasive surgery in the general surgery field so far. And then we also have Doug Eunice, and so Doug is the founder and chief medical officer of Monogrammed Orthopedics. This is another surgical robotics startup in the orthopedic space. And Doug is not only the founder of a company, he's also a client. He is a board certified attending orthopedic surgeon at Mount Sinai Health System in New York City. And he is also the chief of quality improvement at Mount Sinai. So with that, if you guys could just maybe in the order that I presented you, just alphabetical, just give a brief overview and background about your company and what it is you guys do, and we'll dive into it deeper later.
Great. Well, thanks, Nina. Yeah, I guess I start. So my name is Matthias Glastra, and so I'm the chair and CEO of Noventa. We're an $800 million revenue technology supplier to the medical and advanced industrial OEM space. So we provide the mission critical functionality that actually goes inside robots, like motion sensing, vision, photonics. But we also supply other spaces such as DNA sequencing, minimally invasive surgery, 3D printing, as well as broader automation and robotics markets in industrial applications. So yeah, we have a deep and decades-long relationships with the leading OEMs in the world. So we supply all the leaders in the surgical robotics space as well. Where we typically adopt our proprietary IP and to the wishes of the customer in an engineer-to-engineer engagement. And in surgical robotics specifically, like I said, we supply the leading players that you would know, also emerging players that are up and coming. And specifically there, we provide force-torque sensors, position sensors, motors, joint systems, insufflators, with smoke evacuation, and we're of course leveraging also our expertise in the industrial space. Myself, I have a technical background and a business background, and I've run technology businesses for over 25 years in both medical and advanced industrial spaces. So on to the next person.
So I'm Adam Sachs. So our company is Vicarious Surgical. At Vicarious Surgical, what we're doing is taking all of the advances that Matthias just mentioned that have come out in the last 20 years across both industrial applications as well as, frankly, a lot of consumer technology, and applying those to completely re-architect how surgical robotics work. So what we've done is we've created a significant paradigm shift from today's surgical robots that exist with legacy systems in today's operating rooms, which are an application of large industrial robotic arms, to minimally invasive surgery, and shifted that to very small robotic devices, robotic actuators that can fit intra-abdominally and perform a soft tissue procedure under the surgeon's control. So the advantage of this is it's a bunch of advantages, but the biggest come down to a huge ease of use and time savings in the operating room, combined with fantastic access to organs. Instead of triangulating from multiple incisions to one point, you now can work anywhere in the abdomen from one single incision that's placed anywhere, as well as, frankly, a really large and fundamental cost structure advantage that comes from leveraging consumer electronics technology and getting rid of the giant industrial robotic arms in the operating room. And my background, as Nina mentioned, I'm a roboticist. So I studied mechanical engineering, focused on robotics and biomedical engineering at MIT. Spent a little bit of time at Apple working in consumer electronics, which is part of where, you know, the realization of how much of this is applicable came from. And then I've spent the last 7 or 8 years on this company.
All right. I guess I'm up. So Adam's company is kind of in the soft tissue space, which has a whole different set of requirements and demands from my space, which is the hard tissue or bone. So I do joint replacements. I do about 400 or 500 a year, hip and knee. And so the robots in the orthopedic space are really more akin to like a CNC mill or something that would cut metal or wood in a factory. That's kind of what our robots need to do. The robots that are on the market, you know, have done a really good job of creating a market and creating a comfort level among surgeons for robotics in general, but we're kind of working on the next generation. And by that, we mean a robot that not only is time neutral, but will actually save time compared to a manual non-robotic, which is critical. And we're working on a robot that will allow us to move away from kind of generic one size fits all implants, which are, you know, limited and require huge inventories to be carried, and to move into a patient specific, just in time, custom 3D printed implants. So the robot that we are introducing is going to enable kind of mass customization of joint replacement implants. So I guess that's Monogram in a nutshell.
And Doug, maybe we can just take that and dive a little bit deeper and unpack that a little bit. As being yourself an orthopedic surgeon, you have definitely applicable experience in using surgical robotics day to day, and you have a network of peers, some of whom choose to use robotics, some of whom don't. Can you speak a little bit about the kind of the market penetration, because it's not as penetrated in orthopedic surgery as it is in that soft tissue area? And so can you maybe just give us a little bit of clarity on why some might opt to use it, some might not, and what would other surgeons be looking for who are not choosing to use robotics today in your field?
Yeah, so you know, so there's one robot in the orthopedic space that has about 86% of the market in orthopedic robotics. And there are some other robots that kind of split up the rest of that share. You know, so we think there are things about the robot that has all the market share that really work, that are robust and ultimately decrease the surgeon's stress level. And I think that's the key. I think as new technologies come on the market, if they're just kind of cool toys and they don't really kind of decrease your stress level in the OR, the utilization is ultimately not going to be great. So, you know, that's something that we're really keyed into as a surgeon, that kind of tries new technology. If the technology that I bring into the OR does not decrease my blood pressure, I'm not going to really use it. And so, you know, as
you're currently using the Mako, the Stryker Mako.
I use the Mako, and I, you know, I think that it is. So I'm in a teaching hospital where I have residents. It's really, what I like about it is that I can have a resident do a case and not be worried that they're going to screw it up, because the robot just won't let them screw it up. And ultimately, the robot's execution is based on my plan, which I am comfortable with. And, I think some of the other technologies that are coming online, they're just not as idiot proof, for want of a better word. Where Mako has been really, really successful, even though it's relatively kind of older technology, it works, it's robust. It's pretty idiot proof. It decreases the outliers. And honestly, it's changed the way we do the surgery, because we can do things with a Mako robot with 3-dimensional imaging and kind of virtual planning and execution of the surgery that you just can't do with manual instruments, or for that matter, with some of the other technologies that are online. So there's actually a recent paper, and I mean, out 2 weeks ago, looking at how the Mako has really moved the needle on patient outcomes. And it's really the first really good paper that's shown that because it's changing the way we do the surgery and kind of changing the target that we've always tried to hit, patients are actually doing better. So, and I think as surgeons start seeing more data like that, that is definitely going to push more people into using robots. But just to close,
of all the orthopedic surgeries that happen today, about what portion do you think even use robots right now?
I think it's about 20%.
Yeah.
There are 4 companies that essentially control the market for joint replacements. Stryker with Mako controls 86% of that, as I said. But just one other point about kind of barriers to adoption. It's time. If surgeons have a robot that is arguably more accurate, but it adds 25 to 50% surgical time, they're not going to use it. And, cost is another factor, which sadly we're less sensitive to than hospital administrators. I honestly don't really care how much it costs. But I do care how long it takes me to do the surgery. And ultimately, if you don't have surgeon champions, you can't sell the robot.
Great. That's super helpful. Thank you. And so maybe we'll transition to the soft tissue world, and maybe stay on that theme a little bit about improved patient outcomes. Adam, can you talk a little bit about just maybe a little bit more detail about what you mentioned earlier about single port versus multiple access points, and ways that using surgical robotics can help benefit the patient?
Yeah, for sure. So I think to kind of take it back to the single port versus multi-port, and I think for those who are listening in who are not familiar, it's kind of an evolution of surgery from open surgery originally, which there's both open orthopedic surgery. There's also open soft tissue surgery. So we work mostly on the abdominal cavity, where a surgeon will literally take a scalpel, they'll cut through the skin, and then they actually can cut through the muscle fibers to open up the patient. And when you do that, you end up with substantial injury to the patient's abdominal wall. And about 15 to 20% of the time, the abdominal wall doesn't actually end up healing correctly. And that results in a complication. It's called an incisional hernia down the road. So this plus the cosmesis and back to work time benefits are really what minimally invasive surgery comes down to. And the concept with minimally invasive surgery is that you can get those incisions to be small enough, it's about 1.5, 1.8 centimeters or below, where you can actually bluntly dissect instead of cutting through the muscle fibers. So you use a tool called an obturator. You push your way through the abdominal wall instead of cutting your way through it. And when you do that, you end up with much, much better outcomes for the patient, because those muscle fibers are relatively uninjured. You actually drive complication rates down to about 1% from almost 20.
Wow.
But unfortunately, the challenge that it introduces is now that you have to do everything through these tiny incisions, through these keyhole incisions. So with multi-port surgery, you make multiple incisions around the patient's abdominal wall, and then you triangulate to a single point inside the abdomen where you're operating. And the challenge of that is that the kinematic profile of the instruments all depends on those incision sites, because you pivot about the incisions. With existing surgical robots, there are these large industrial robots that hold instruments. They add a wrist, which helps a lot with suturing inside. But at the end of the day, you still have the kinematic profile of the robot being defined by the surgeon for every procedure based on where they put the incision. So what that means is that multi-quadrant surgery is really difficult. If you are wrong about the surgical site, it's really difficult. And you end up with collisions inside the abdomen and collisions outside the abdomen. So all of this has led to a lot of challenges. And that really brings us to what we're doing, which is single port surgery. There have been a few attempts at this in the past, but they've all been built on flexible robotic technology. Flexible robots are just, frankly, they're too flexible that even to do the lowest force surgical procedures, they end up with a 2.5 centimeter incision, which leads to complication rates that are starting to approach open surgery again, like 8.4%, because you have to cut through the muscle fibers again. So what we're doing is using our own design of robotic technology to actually give the surgeon 9 degrees of freedom inside of the abdomen, give them these wrists, elbows, and shoulders inside of the abdominal cavity, all through a single incision of 1.5 centimeters that can be made with blunt dissection. So that the goal of this is once the surgeon is inside, they're just free. They're able to operate. I totally agree with everything Doug was saying about procedural time. I mean, time is everything in the operating room. It really is. Surgeons and hospitals are both frequently paid per case. They're reimbursed per case. So if you can literally half the time, you can double the revenue without changing the cost basis significantly for the hospital or the surgeon. It's a huge difference and something that really drives adoption. If you take the converse of that, which is existing surgical robots in the soft tissue space, which, just to be clear, have an incredible market and have done wonderful things for a few percent of patients, but they're stuck at a couple percent adoption. And the reason is that they add significant operating room time plus significant other costs. And if you go to take one particular procedural example, from 2 hours in a case to 4 hours, you literally go from in an 8-hour shift being able to do 4 patients per day to 2. You half your revenue. So
Adam, are you guys doing outpatient surgery, or is everything that you do inpatient?
It's mostly in the beginning gonna be the hospital outpatient setting. I think it's we're not on market yet, but it'll be across all sectors. I even personally think one of the most interesting is the ASC setting, which has been almost impossible to penetrate with robotics because of the cost basis. But given that we have a nearly 10x cost of goods advantage because we're getting rid of these large robotic arms and making the system much smaller, it's really just a tiny little robot inside the abdomen. It gives us a fundamental advantage that will allow us to tap the ASC market as well. But it's not where we're starting. Hospital outpatients where we're starting. And to directly answer your question,
like a pivot to maybe a bigger, like a bird's eye zoom out view. And maybe Matthias, you can address this one for us. If you could just share with us kind of the end market that you're looking at, because you not only deal with robotics in healthcare, but you also deal with it in industrial. But as I understand it correctly, in 2021, your medical division grew rapidly, largely led by the demand that you're seeing specifically in surgical robotics. So I'd love to hear your perspective of the current market, and then where you see the upside, the penetration opportunity. You had such strong growth in your healthcare division last year. Is it already widely penetrated? Is everybody already using automation and robotics that could possibly be using it? Or do you have confidence that there's going to be continued demand? So I'd love to hear your thoughts on that. And just so everyone knows, we've been holders of Noventa for years, since 2018. And this stock has returned over 140% since we first brought it in. So it's a less known name, I think, to a lot of investors when it comes to robotics and surgical robotics exposure. But again, we just don't want people to forget about these enabling technologies behind the scenes as well. So anyway, Matthias, if you could please share with us.
Yeah, listen, I think really what we're talking about here is productivity, right? At the end of the day, that's do things cheaper, better, faster. And if you look at the industrial side, of course, the run for cheap labor is over. So countries and companies will have to get on the automation and robotics curve, right? And so, of course, automotive is kind of leading the front there. And actually, with the investments in electric vehicles, it's rapidly accelerating. Again, next generation robotic technologies, right? Because you got to handle these big, batteries, for example, that are very fragile. So there's a lot of investments going in that area, and of course, there's, I think Adam mentioned this, you can actually piggyback on that on the surgical and the medical side as well. There's a lot of these technologies that are, of course, are porting over. So I think also on the medical side, so we're excited about the overall automation and robotic space in general. We think it's a multi-decade long investment curve, quite frankly. Penetration is still fairly low. You see, robots being used together with people. That's of course what you're going to see more and more on the surgical side as well. That includes all kinds of sensors and safety mechanisms that have to get included deeply inside the robot. A lot of redundancy, so that it's literally idiot proof, right? And that no issues can occur. Now, on the medical side, we feel that penetration is still fairly low. I mean, according to our data, it's less than 10% penetrated. And it depends a little bit on the application, right? So maybe a little bit more in orthopedic side, but in soft tissue, we feel that that's much less. I think Adam has a really cool, exciting new way. What you see is miniaturization there. And for us, what was interesting actually is that even though hospitals were cash strapped as a result of COVID, the robotic surgery placements were actually accelerating both on the orthopedic as well as on the soft tissue side. I mean, we literally serve all those modalities. So whether it's orthopedic, neuro, lung, right, soft tissue, also service robotics, which is basically not robots that are necessarily operating, but are helping surgeons hold tools, or kind of, it's more of an auxiliary use for longer procedures. We see rapid increases there as well. And so we personally think it's just the start of, again, a multi-decade long investment trend. And of course, robots will have to get smaller, they have to get cheaper. And I think it was mentioned a few times before, is that, again, it's about productivity. You need to get the amount of procedures per day per robot up, right? And that is a pretty complicated orchestration of things. There's a lot of workflow improvements that need to happen. And of course, if a robot is smaller and more integrated into, let's say, the workflow, it's easier. The last thing that I would say is that we talk a lot about the robot itself, but is, of course, you have to see, feel, move around, and actually do the procedure, particularly in the soft tissue side. So there's energy devices, there's insufflators, there's cameras, all have to work in unison. So if the easier you can make it for the surgeon, so that actually by sometimes even simple head movements, you can actually have a integrated way of driving the procedure, you will have less issues, and you have less time lost, and you actually need less staff. So all these things. So we're actually helping also on the visualization, and so the non-motion side of visualization and the insufflation side, and helping that to integrate that with the robotic procedure, which we feel is really critical for workflow improvement.
And as I understand correctly, those different parts beyond the robot in the OR are areas in which Noventa can provide technologies that go into
That's right.
everything you just named.
Yeah, yeah.
And the
So
importance of them
we're
being integrated is that they all do have to work in unison. So if somebody were to say piecemeal those parts from different organizations that were not previously integrated, would that potentially compromise the surgical procedure?
Yeah, it could. I think there's a few benefits of that. Yeah, we basically combine, let's say in the motion, different technologies into subsystems. So it's actually more in one hand. So we actually can provide a more turnkey solution to the surgical OEMs. In case of the insufflation, which we provide as well, which is basically, Adam was talking about the abdomen, so the belly of the patient. In order to see, you actually need to insufflate the belly with CO2 gas. We're the leading provider there, but that needs to very closely be integrated with, let's say, the energy-based devices and other pieces of the robot, and that actually saves time. And we're the leading provider in what's called smoke evacuation insufflation. So, as some of you may know, is that when you actually start a procedure and you cut with energy-based devices, you produce surgical plume. That surgical plume is often toxic. Yeah, so when the hospital staff actually sits next to a robot or actually an energy-based device, then that equates to about smoking a pack of cigarettes a day. So, and particularly with COVID, of course, that was people were not very fond of that. So having those type of technologies that makes it safer also for hospital staff, and while actually improving workflow is our trends that we see.
That's very helpful. And maybe we will just, sorry about that, the doorbell just rang. Maybe we could just pivot back to Doug here and go a little bit deeper now into the technology. And you did mention earlier some differentiating elements of your technology, but maybe we'll just give everyone a chance to nerd out a little bit and just share exactly, like, for example, Doug, as I understand it correctly, you're really revolutionizing what's happening with orthopedic surgery, or you intend to, with an innovative way of attaching parts to the bone. So if you could just share a couple of things, you're going to be using 3D printing as well, just some ideas that you have near term, long term. And yeah, this could be a couple years out, this could be 10 years out, but where do you see the market going? And with penetration so low, it really seems like it's fair game for new market entrants. So if you've got something that's really differentiating and potentially preferred by orthopedic surgeons, made by orthopedic surgeons, it's quite a compelling investment story. So we'd love to hear more about that.
Yeah, I mean, I think where things are going is because of 3D printing. 3D printing is making it possible, from a time and cost standpoint to 3D print custom implants. I mean, it's just, we've been able to make custom implants for years with kind of traditional manufacturing, but it's really expensive and it takes, the turnover time is months. We can 3D print a personalized knee replacement in 12 hours. And it's not, it is becoming kind of the standard way that we make implants pretty quickly, because it is becoming cost effective. There's less raw material waste. You can come out with new products quicker because it's faster to prototype, faster to manufacture. You don't need to build out a whole manufacturing pipeline. So 3D printing with customization is definitely coming. The other part to that puzzle is to have tools that kind of allow us to fully leverage customization. So the current robots and certainly manual instruments, which are fairly, fairly crude, they're really chisels and saws and like stuff you'd use to kind of like break rocks with, they're not like high precision. But so if you can develop tools such as the robot we're working on that can custom prepare the bone to create cavities that with a really high tolerance can fit these custom implants, you can create much less invasive implants that are much more stable, theoretically much longer lasting, and just clinically better because they just fit the patient better. So that's kind of what we're doing that I think is somewhat novel, is that we are designing a robot that is going to drive what we think is the inevitable customization of implants. because, you know, the customization piece of this is not, it doesn't just make clinical sense, it makes huge economic sense, because you know, one of the reasons that there are only 4 companies essentially dominating the implant market is that it requires massive inventories. Like their inventories only turn over like once a year. And so the barrier to entry is really high. So the little players can never really get a foothold. But we think the market is ripe for disruption there. You know, if you have a way to really make it possible to give everybody their own custom implant, I mean, you've solved 2 problems. You've solved the big business problem and some big clinical problems too. And then I think the other thing that we're, as I mentioned earlier, that we're really keyed in on is speed. You know, we can now cut a knee in 4 minutes, which is insane. Like doing it manually takes about 20 minutes or so. So we can actually, with our robot, cut a knee in 4 minutes. We can register the bone, which is kind of the way that we tell the robot where the patient's bone is, so they can be tracked. We can do it in 30 seconds. It now takes like kind of the other systems that are out there. It's about 4 or 5 minutes. It doesn't sound like a lot, but it really does add up. And so we think that we're really kind of teed up well for surgery centers, because that's where this is going. I mean, and COVID has really pushed us. The wind is at our back. I mean, COVID has accelerated this pre-existing trend toward doing outpatient joint replacements, because you now don't have to convince patients not to stay in the hospital. They don't want to be in the hospital. So it's really like turbocharged this trend. So, you know, it's forecast in the next 5 years that 60 to 70% of joints will be outpatient. I mean, like I can tell you, just speaking for Mount Sinai, we're building out right now as we speak a spine and joint only surgery center, because that's where the market is going. And we're going to need technologies that are well tailored for that space. As Adam said, size is a part of it, cost is a part of it, speed is a part of it. The other part of it is just decreasing outliers and complications. You know, one thing you cannot have, I mean, it's not good anytime, but in a surgery center, you cannot have complications. You can't have readmissions. They're just not set up for it. So, you know, that's another piece of you know, how we're going to lend ourselves to that setting. So
can we maybe talk a little bit about the current healthcare environment, as everyone is well aware now, is really strapped for resources. There's just not enough people to do the work that is in demand right now. The healthcare worker shortage, and that is expected to continue to get worse over time. It was exacerbated by the pandemic, but there just aren't as many people coming into the nursing and the physician field at the rate at which they're needed. And meanwhile, the global population is growing older, and the number of people living longer lives is also expanding. So part of our thesis, broadly speaking, in why we see 10 years of a long tailwind of growth in healthcare technology is that there is an imperative need for adoption of automation, robotics, and AI, particularly in healthcare, largely in healthcare, because it is already so underpenetrated. Healthcare only just got digitized in the last decade, really, and it still has so much more to go. And on layering on top of the digitization now are all the med devices, and then getting them integrated and getting them to interact with one another. So could we talk a little bit about how surgical robotics will help address the shortage of healthcare workers, if not immediately, like over the long run? And I know, Doug, you mentioned readmission rates. So maybe Adam, Matthias, you guys could touch upon a little bit where you can see how your technologies will help address healthcare worker shortage.
Sure, I'm happy to jump in here. I think that, all right, let's start with the most, first of all, I totally agree with your thesis. I think it's actually something that not enough people talk about. And it does have, you know, a 10-year horizon, but the both economic and clinical benefits over the next 10 years on this are going to be incredible. I think to start with the absolute most obvious example, I mean, let's just go back to cutting procedure time. right? If you can have procedure time, you double the output of the same team, the same surgeon, the same staff. The readmission rates absolutely, and decreasing complications and reoperation. It's a huge potential benefit to patients and to the hospitals or the payers, depending on when it happens.
And just to clarify to the generalist audience, largely generalist audience, because there's not everyone might have a healthcare background, but readmission will occur if somebody, say, has a surgery, gets discharged, goes home, gets an infection, or some other acute need potentially related to that surgery that they had, and then they have to go back to the hospital. So this further is a drain on healthcare worker staff time, but also often with readmissions in certain circumstances, the hospital doesn't even get paid. Because if it was the hospital's fault that the patient got an infection or if something happened to them, it might limit how much revenue they generate. So now they're strapped for staff time and then not potentially getting paid as much as they could be for looking after the patients who have to come back later. So anyway, I just wanted to fill in the audience.
I mean, in some cases, Nina, we're actually in orthopedics, we have these bundled payments. We're actually getting penalized where they actually have to pay for, the hospital actually has to pay a fine for X number of readmissions and long lengths of stays, et cetera. So there's actually punitive stuff going on, which has never really happened before. So.
Yeah, there's huge advantages to all of that. But that's only scraping the surface, because I do think that there's a lot of potential for automation. Like one of the reasons, just to talk about us specifically for a minute, that we've instrumented our device with all of these sensors so that we actually measure every movement, every force, every, that's exerted on the tissue, as well as map the abdomen in 3D in real time so that we actually know how the tissue is deforming. It's so that our AI team can build out automation on this, because I really believe that over the next 10, maybe even 20, 30 years, we're going to get more and more and more automation, starting with things that we're already seeing in laboratory settings of autonomous suturing tissue, and moving out to actual autonomous procedures to some degree. And I think that, a lot of people always wonder, like, how will you get surgeon buy-in on this? It's easy. There's not enough surgeons. Exactly. Surgeons work extremely long hours. It's going to be easy to get surgeon buy-in if you can allow surgeons to do more cases per day and to avoid the monotony of surgery and focus on the thing that really takes their intelligence and training, which is choosing which surgical procedure and designing the procedure for the patient.
Yeah.
What are your thoughts, Matthias?
Well, a lot of great things have been said. I think maybe to build on Adam's point here, I think with a lot of these sensors and a lot of data being generated, right? So I think with that, we're just seeing the tip of the iceberg in terms of ultimately the effectiveness of procedure, because you can actually start to analyze these procedures. You got thousands or millions of these procedures being performed, and actually you start to it's not becoming a doctor specific anymore, but it's really going to be, okay, how do you do this procedure? And it's almost like a manufacturing plant, right? So I used to work in a semiconductor plant. We all talk about TSMC right now. You know why TSMC is so good? Because they measure every nanosecond, every process, every aspect of it. And you will not have quality if you don't measure it, you don't actually drive it, you don't have what it calls a manufacturing execution system, actually looking at it in real time. And you do that across hospitals, across healthcare systems, et cetera. Now, there is some privacy involved. There's, of course, cybersecurity is going to be a huge element. So you got all these other challenges that come with it. But let's say we will resolve those. I think you start to just unleash an amount of power, because you actually start to get insight and actually data that goes across all hospitals, across all countries. Yep. And that, I think, is currently, personally, I think, limiting the healthcare system, because you're just not scaling up, because you're not getting on the learning curve, because each procedure for each surgeon does only, I don't know, Doug, how many you do, but it's not like 10 million, right, a year. So that's, I think, personally, I think getting that learning effect of the system up is, I think, going to be huge.
Yeah.
Where do all of you see AI playing a role, whether it's with your companies or within the hospital, within the OR?
I can talk to that because we have an AI component to our system. So we start with a CAT scan of the patient's joint, and you have to identify landmarks in the bone, and basically create a 3D model. And the current way that that's being done with most systems is manually. So you've got a person going through slice by slice and kind of drawing out the relevant landmarks. We have AI algorithms that are ridiculously accurate. They're 99.99% accurate. And so we can create a really accurate model of the patient's bone without any, I mean, other than us kind of checking the model, with no kind of laborious human intervention. And back to your earlier point about kind of automation and healthcare worker shortages, I couldn't agree more with that. And we specifically see, when you look at the growth in markets for joint replacements, it's India, it's China, it's places like that, which are like 15 to 18% year over year growth in their markets. We're like low single digits in the West. So you look at those markets and they don't have nearly the number of fellowship trained joint surgeons that can do all these procedures with their exploding middle classes that are going to be necessary. So with a platform like ours, which is automated, where the robot is actually, once somebody presses the button, it's going to take its own path. You can have a surgeon at a central location with the AI generated model, create a plan that makes sense for that patient, create implants that make sense for that patient, and then have people with kind of minimal training operate the robot remotely. And in fact, we are doing that experiment where I'm going to go down to Austin and expose a knee, set it up for the surgery. And then my 16-year-old son back in New York is going to have the foot pedal, and he's going to actually drive the robot from 1,500 miles away, as just to kind of demonstrate that this is actually possible. And I think it's going to be tremendously helpful in some of these emerging markets.
I totally agree with everything you just said.
We can see some decentralization happening, as you guys have mentioned, more healthcare outside of the four walls of the hospital, more opportunities to take place in surgery centers, in emerging markets. And so I guess if we could just pull back to kind of the market opportunity here, because I really want to make sure that investors leave here today understanding how much upside potential there could be, where we've got less than 20% of all the surgeries that could possibly be using robotics are even using robotics today, or less than 10% in some circumstances, as Matthias shared. And then we've got more ambulatory surgery centers. Mount Sinai is building a brand new facility to help meet the demand of people who need surgeries, and we're seeing expansion and potentials as I guess more AI is being deployed, as 5G is further adopted. There's potential for telerobotic surgery and for providing greater access to care to people all over the world, not just people who live near New York City and Mount Sinai or near a large city. So a lot of upside potential. And we did touch on this briefly before, that Noventa is seeing strength within its surgical robotics growth. I like to use Noventa also as an example, as kind of a proxy and a leading indicator, if you will, of this potential growth opportunity. You guys have had double-digit or maybe potentially 20% growth in your surgical robotics. Is that sustainable? And what gives you confidence on that? And I like to bring that up also because you guys recently reported record bookings and record revenue growth during the pandemic. This is a tough year. You're amid supply chain constraints, and yet you're still seeing top line growth. To me, that is a huge leading indicator of end market demand. And I'd love to hear more about that.
Yeah, so of course we're not only exposed to robotic surgery, but it's an important market to us. So we also see huge demand in DNA sequencing, for example. Similar actually trajectory, quite frankly, very early stages in penetration. You see massive acceleration of adoption. I think the other two panelists already said, you clearly see confirmed patient outcomes. And I think, we got to just drive the cost productivity curve together, right? But yeah, we're excited. We see double-digit growth for the foreseeable future, and yeah, but with that, new technologies, new innovations will have to happen. I think we talked about those. I think the panelists here have some really cool new ways of approaching this. So I think we'll hopefully see more of that. And so yeah, we see growth this year, but we see growth in the coming years. So there's double digits in this area, at least from our perspective.
And great point, not just in surgical robotics, but across healthcare tech, in genomics, for example, and
That's right.
diagnostics, et cetera. In fact, you provide automation enabling technologies in the laboratory as well.
That's
So
right. Yeah, well, it's similar thing. There's people shortages there too. So you see that across, I think, many industries that, yeah, we don't have too many PhDs that can actually launch kind of tests for lab equipment. So that will become fully overhauled with with new automation technologies that we will hopefully provide. So I think, yeah, there's multiple areas where this is relevant, not only surgical robotics.
So to put this into perspective for investors, everyone's heard of Intuitive Surgical, that's been following the surgical robotic space, world market leader, pioneer, and a phenomenal company. They are members of multiple portfolios at Robo Global, our Robo, as well as our H-Tech portfolios. When they IPO'd in 2000, probably a market cap early in their days of a couple $100 million. And last year exceeded 100 billion in market cap. And so, and that's over a 22-decade or so time span. I just wanted to highlight that as an opportunity because that's the buck doesn't stop there. Like that's one company, but we've just heard for the last almost 45 minutes or so about how much more opportunity there is for surgeons to be using robots and for new technology to be disrupting the space. And so while we are holders of companies like Stryker with their market leading technology with Mako and Intuitive Surgical, there are room for other companies as well, because we see over time, not only room for new entrants, but for their market caps to grow also, and for there to be multiple players in the tens of billions of dollars worth of market cap. And so, so here we have a situation where we're seeing high end market demand. We have companies actively growing, and there's been a large market pullback. So as many people are already aware, a lot of tech stocks have sold off recently, and that largely includes healthcare tech. And so I also like to pick on Noventa as a leading indicator because one of the concerns as people kind of de-risk their portfolios and pulled back a little bit from healthcare tech was concerns about the small mid-cap companies and their inability to be able to maintain profitability and to drive operating leverage over the long term. And Noventa recently reported that they're in the process of passing along a price increase. I bring that up just to point out the pricing power of innovative companies. If you are truly bringing something to market that is helping hospitals address healthcare worker shortage, address cost needs, and help drive more revenue, do more surgeries per day, these are the types of technologies that are continuing to see demand, even though there has been a global pandemic and other geopolitical and macroeconomic issues pulling back stock valuation. So this is a great opportunity to get involved with some really strong companies and strong investment opportunities. And so we talked about a couple companies here today. I will mention briefly, we've got the Robo portfolio that does it does encompass healthcare technology as well as several other economic sectors. Robo is a portfolio that offers not just robotics and automation companies, but the enabling technologies behind the scenes. And it is the Robo Global flagship, and it trades under the ETF ROBO. And then through our knowledge that developed there with the Robo portfolio, we were compelled to launch a separate technology solely focused on healthcare, because there is so much innovation happening there and disruption that we believe over a long tailwind. And so the H-Tech portfolio is another way for investors to gain exposure to multiple companies that are providing this type of disruption with surgical robotics and more across other areas like genomics, et cetera. But if you don't want to buy a whole portfolio or invest in a whole index, there are ways to invest in these companies individually. Monogrammed is actually not publicly traded, but they did something very interesting, and I'll let Doug share that.
Yeah, so we kind of had a chicken and the egg situation where in order to attract institutional investors, we needed to have a company, but we couldn't have a company without big investment because it's just expensive what we're doing. I'm sure you guys can appreciate that, Adam and Matthias. But so we needed money to put a team together and to build enough to kind of get the big money that we were going to need. And so we turn to the crowd. So we turn to crowdfunding through some relatively recent changes in the law that occurred under Obama during the some of the Recovery Act stuff. But so we did a Reg A plus. We've actually done 2 Reg A plus crowd funds. Our Series A, we raised almost $15 million. Our Series B, which we just closed, we raised almost 24 million. So we've done really well. I mean, we really, I don't think could have raised that much from institutional sources for the stage that we were at. So now we're kind of in a position where do we actually go to the VCs and stuff, or kind of we're doing okay with the crowd, and there's some real good advantages. Like we maintain control, we're not giving away board seats, we're more in control of our valuations. So we're going to do at least another round or 2 of crowdfunding, and then we'll see where it goes. And then at that point, we're just going to need growth capital, which is kind of a separate thing. So we'll probably go to institutional at that point. But yeah, we've been thrilled with it, and anybody that's interested in crowdfunding, we're happy to share our experience.
Great. Thank you for that. And Adam, maybe you could share with us a little bit more about, I know you talked previously about potentials for cost structures to come down, but also how you can do and offer what you're doing at scale. I know initially you're targeting hernia, but your technology is not really meant to be niche and only cover one specific indication. So can you talk about where your technology can go and why it can do this at a low cost?
Yeah, so fundamentally, the reason we're able to do what we're doing at so much lower cost just comes down to reduction in complexity, reduction in the overall size of the systems. It's leveraging a lot of, frankly, cell phone technology. I think the best example is cameras. We've gotten, really only in the last 2 years or so, we've gotten to the point where cell phone cameras are actually better than surgical cameras. And we buy ours for something like $10. That's lens stack, focusing mechanism, and sensor all together. It's really an incredible opportunity to leverage cost of goods advantages that just do not exist in conventional medical devices. And it's kind of, to some degree, outside of the box that is existing medical devices, and bringing things from consumer technology in. So it's that combined with the fundamental fact that we don't have 4 gigantic robotic arms in the operating room anymore, and instead have one tiny little robot and a non-robotic system supporting it, that gives us such a huge fundamental cost of goods advantage. Sorry, what was the second part of that question?
Gosh.
That was a good answer. That was good.
I think you touched on it.
All right, we'll go with that.
It's Adam. We actually just got an NSF grant just you mentioned bringing consumer electronics in for something really similar. We have these tiny little cameras the size of like a die that are like they're disposable, and they're so small. We can just put 3 or 4 of them inside the patient's incision and use that for tracking instead of using these huge cameras that have to see into the patient. But we got them from the gaming industry. They use them for gaming.
And I think each of these, it's really about the time that you do it, right? 20, 30 years ago, actually closer to 30 years ago, when the first generation of surgical robotics was architected, it was architected based on incredible industrial robots. And that's what existed at the time. And developing, even low resolution cameras was a multi-$100 million endeavor. Now we have these incredible high resolution cameras. Actually, it's probably a multi-billion-dollar endeavor to develop them, but we can purchase them, as an off-the-shelf component and integrate them into our device, spending none of the R&D money on it and getting all of the benefit of volume.
Yeah.
So it's a pretty incredible difference from what existed and what was even possible 20 or 30 years ago.
Yeah, and I do think there is still, at least in orthopedics, among some of the companies, there's still kind of a reluctance to accept the commoditization of things like robotic arms. Like there is a feeling still that it should all be kind of in-house, which should be proprietary, blah, blah, blah. But the truth is the cost and quality of platforms that are readily available and designed to be open platform for just people to develop applications, like that's what is going to happen. That's inevitable, because it just doesn't make any sense. There's no bandwidth, constraints. The cost is better, the quality's better. So it's just a matter of people like us finding the right platform and then developing the application for it.
Taken a couple questions that have come in, and maybe we'll touch on another one. And Matthias, I'll send this one in your direction. Where do you see USA versus global opportunity, maybe near term and over long term?
In surgical robotics? Yeah, I mean, listen, I think it's been a US-led revolution so far, right? But that, like with everything, that will change. So if I take DNA sequencing as an example, you see, Chinese players coming up pretty rapidly right now, for example. So, while still the leader is, of course, Illumina and driving hard. China has under 2025, they have robotics as one of their top edicts. So you can just rest assured they've rolled up multiple other industries. So I think it's just a question of time, quite frankly. So we're a global player. We serve people globally. You see in Germany, there's of course strong robotic expertise. There's a lot of let's say, of course, you got Boston as a robotic hub, but you also got Odense, Denmark, Barcelona, right? So you got a lot of these emerging areas that actually are in Europe. So I do think this will become a global playing field. In surgical robotics, the US definitely has an advantage and is out of the gate. And I think the Europeans will have to fight hard to catch up. I think we got to watch the Chinese. I think that's probably where the quickest and most investment will go, actually.
With our remaining 2 minutes, I'd like to just maybe give each of you a chance, if there's something else that you wanted to talk about today and you didn't get a chance to through our Q&A and our organic discussion, maybe just each of you can take a turn and let us know what else you'd like to hear, what else we'd like to hear, we should hear.
No, listen, I think the other panelists shared it well. I think there is a lot of other markets where robotics is being used, or other technologies like consumer electronics, that the medical field can take their advantage of. And I think in general, medical technology, the market has been shielded, right? And what I believe is going to happen is that product life cycles will actually shorten, innovations will have to go up in terms of speed. just to keep up, because the technology evolution or revolution is going so fast that actually players will have to adopt and somehow find a way to actually introduce quality products into the market. One thing we haven't talked about is the FDA and or the regulatory environment. So I would say, while this revolution is happening, actually, I do see a slowing effect from the FDA on some of these technologies. So because it needs to be proven and safe, et cetera. So there is a little bit of a word of caution there that so far, well, there's great technologies out there. Actually, the FDA is very stringent, and rightfully so, in making sure that these technologies are all qualified. And, you know, qualified in consumer electronics doesn't necessarily always mean qualified in kind of within patients. So that's the only thing we haven't covered. And of course, yeah, we get audited indirectly, and I can tell you it's pretty stringent. So that's the only other thing that I wanna share.
Thank you. How about you, Adam?
I'll go real quickly since I think we're at negative time. Just emphasizing, you know, orthopedics, even as the highest penetrated in robotics, still, you know, 20%. We think soft tissue is about 3% penetrated overall and that's just addressable, you know, procedures that are addressable with today's technology. So there's going to be a number of winners, but in this space, but winning is about providing value. Right? It's not about making a cheap copycat version in medical devices. It's about providing better value to the surgeon, to the patient, to the hospital, to the payers.
Great, thank you. How about you, Doug?
Yeah, I guess what I would say is, you know, one of the big knocks on orthopedic robotics has just been the clinical benefit has up until very recently been unclear. And I think that's because the robots have been used to do a better job of hitting the same old targets that we've always tried to hit. And what's starting to become clearer and clearer in that robots are allowing us to figure out what the right target is. And as that happens and we use that data, it's going to really start driving in a rapid way wider adoption of orthopedic robots, because the clinical benefits is just starting to happen are going to become much clearer.
Great. Well, thank you all. We did go over. I apologize for that, but I'm so grateful that you took the time today and to join us at Robo Global to provide this this deep insight into surgical robotics to our investor community. So thank you all for dialing in and for joining us, and to our panelists. We're really so grateful that you joined us.
Thanks so much.
Take care, guys.
Take care. Good night.